Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2021 VCA Maths Methods Exam 1. I've had students in my class telling me, hey, can you go through this paper, please? There's some questions that are very difficult to understand the concept. So yeah, let's go through this paper and yeah, let's try it out. So, question 1a. Differentiate y equals 2e negative 3x with respect of x. So 1 mark. So just give your answer. So that'll be dy dx. Okay. Let me write nice. So it'll be just dy dx equals, so negative 3 multiplied by 2e negative 3x, which is equal to negative 6e negative 3x. That should be your answer for question 1. 1 mark. Just this. Next question. Evaluate f dash of 4 with this. Okay. So what we're going to find is f dash of x. So f dash of x. So this is the product rule. So I'm going to line this up and just say u is x. V is root 2x plus 1. Now u dash is 1. V dash should be, so the 2 over 2x plus 1. Okay. Now, multiplying these, we're having, so it'll be x all over root 2x plus 1 plus root 2x plus 1. Now, f dash of 4 is 4. So 4 times 2, 8. So that'll be 3 here. Plus another 3, which would equal, so what is that? So 4 plus 9, which is 13 over 3 as your answer. Okay, that's not bad. Question 2. Let f dash of x equal this. Find f of x given that this. Okay, so what we're going to do to find f of x, we're going to integrate x cubed plus x dx, which will be x to the power 4 over 4 plus x squared over 2 plus c. We don't want to forget that, plus c. So now, given that f of 1 is equal to 2, so it'll be 2 equals 1/4 plus half plus c. This will so quarter plus half is 3/4 plus, is that right? So okay. Therefore c is equal to 2 minus 3 over 4, which is 5 over 4. Therefore, your final answer, f of x, is equal to x to the power of 4 over 4 plus x squared over 2 plus 5 over 4. Okay, I hope I haven't made any algebra mistakes over here. Let's go to the next question. Okay, it says consider the function where g is this, g of x is 2 sine 2x. State the range. Okay, so the range, oops, what happened here? So the range for this, so your range of g is equal to negative 2 to 2. Period of g, so your period of g is, so period is 2 pi over n, which is 2, which is equal to pi. Solve 2 sine 2x equals root 3 for x is an element of all reals. Okay, because it's an element of all reals and it's not restricted, it means that it's a general solution as the answer. So okay, so it'll be sine 2x equals root 3 over 2. Okay. Let's really look at this. So if I'm going to draw a nice diagram here of a unit square, unit circle. Okay, something like that. A little bit just, okay, something like this now. Okay. So, because we can see, okay, this is, oops, what happened here? Damn, what happened to the, okay. Okay, okay, perfect. Okay, so because this value over here is a positive, so you sign this positive, we know by cast, so cast, where sign's positive at this over here, and also over here at this place. And we know that the base angle is, at this point, would be pi on 3. Okay, and also this one will be pi on 3. Okay, so what can we write as a general solution that will give us a repeating factor of those? Okay, so we can say 2x is equal to what? Okay, we can say 2 pi n, so 2 pi n plus pi on 3 is a general solution, because if you think about it, okay, so when n is equal to 0, okay, actually, let me just move this. Let me move this and make it bigger. Let me just here. Okay, perfect. So, also, I need to make sure to write where n is an element of all integer values. Okay, so if we subbed in n equals 0, it will give us pi on 3, which is true. That's one of the solutions. What about n equals 1? So it'll be 2 pi plus pi on 3. Again, a full rotation still gives us the same value. So any value n you can put in there will give us this value over here. So that's good. But remember, there's also another solution, which is also this one. So what equation can we make as a general solution to give us? Well, can we say 2x equals 2 pi n plus pi, so minus pi on 3. So what I'm saying, okay, so think about it like this. So we're saying 2 pi n, so any value of pi, 2 pi, so any rotation will give us, so we'll be here, and a pi will give us here, but we minus pi on 3, which will leave us to this solution. And we can do that infinitely using this equation perfectly. So these are your two general solutions. So now I'm just going to simplify them. So, okay, I am just going to move this and make it, okay. Let me just put it over here. Okay, so, all right, so this one over here can be written as, so this can be written as 2 pi on 3, so 2 pi on 3. And both equations can be written as 2x. So the first one can be written as, so it will be written as, okay, 6 pi n plus pi all over 3. And your second equation can be written as 6 pi n plus 2 pi all over 3. All right, so we can take, for the first one, we can take pi as a common factor we can see. So we can say pi, so we can say pi 6n plus 1. Is that right? Yep, looks right for this one. Yep, so 6 pi n 3. All right, perfect. And for this one too, we can we have a common factor of 2 pi. So we can rewrite it as 2x, so 2 pi. And we can say 3n plus 1 all over 3. Okay. And then we can just rub this one out and replace it with that one. Okay. Now we need to get rid of that 2x to make it only x. So To get rid of that, we'll just make this a 6 over here. And that will therefore get rid of this 2. So x is equal to that. And to get rid of this, we can get rid of that. So your values, this is your general solution over here. Nice general solutions. And don't forget to always end your general solutions with your n is an element of all integer values. This is important. Okay, perfect. So these are your solutions for this question. And I'm just going to make sure n over here. Not too bad. Okay. All right, let's move on to the next question. Question 4. It says, sketch the graph of y equal this, okay, hyperbolic function on the x is below, label asymptotes with the equation and the x-intercepts with the coordinates. Okay, so let's do that. So we know that there's going to be an asymptote at x equals 2, so it will be, so at x equals 2. We know there will be asymptote at x equals 1, so what we're going to do is, yep, so y equals 1. And the graph will look like, so, okay, let's find the actual y intercept. So for the y-intercept, we're going to just say y 0, which is 1 minus 2, negative 2, which is 1 plus 1, 2. So over here, that's your y-intercept. What about your x value? Well, let's solve it. So we want to solve for yx equals 0, which will be 1 equals 2x minus 2, which is 2. X minus 2, x is therefore equal to 4. Right over here. Nice. Now, let's just sketch a nice graph. So let's use the color blue. So it'll look like this. It'll go down. This one will look like this. And it will go down. Okay, perfect. Now, what we want to do is we want to act so... Okay, so so this one is 4. Okay, this is, oh, yuck, ugly. Okay, let me write it nicely. So this point over here is 4, 0. This point over here is 0, 2. That's it. That's it, yeah. Let's move on to, okay, next question. Find the values of x for which this, okay, this graph, y, is greater or equal to 3. So to do this, I'm going to actually draw. Okay, what I'm going to do is I'm going to take a screenshot first. I'm going to take a screenshot of this and do this. Okay. So I'm just going to take a screenshot of this. Okay, perfect. Let's go over here and use that screenshot to our advantage. Okay, here. So what I'm going to do is I'm going to draw a line of y equals 3. And I'm going to, okay, so y equals 3, which is over here. Perfect. This line is y equals 3. And what we want, so y equals 3 is this red over here. And the blue graph, which we've drawn, is this one over here. So what we're saying is, what are the values of x for the blue graph, this blue graph, to be greater? Where is the blue graph greater than the red graph? Well, we can see that it's greater at this value over here. This over here. So it's greater from here, this point over here, to over there. So we can say, to find that point, we're going to actually solve it. So we can say, what's 1 minus 2 over x minus 2 equal 3? So it's just negative 2, 2x minus 2, which is negative 1, x minus 2. And that will be negative 1 plus 2 equals 3. So x is equal to 1. So this value is x equals to 1. So now what can we say? Well, we know that x is equal to 1 there. We can say when, so x is an element, we can say x is an element. So x is an element from negative 1 to not included. The 2 because there's an asymptote. It approaches the asymptote but never touches it. So yeah, we say from, and what am I saying? Negative 1. 1, sorry. 1, 2, 1. So 1, 2, not inclusive. That's what I'm supposed to do. All right, that looks right. 1 mark. Nice. So let f equal f of x, g of x equals this. The graph of f and g have a common horizontal. So horizontal is just x-intercept. So common x-axis intercept at t equals 0. Find the coordinates of the other horizontal intercept of the graph of g of x. Okay, so we want g of x. Okay, g of x to equal 0. So we're saying that for x minus 1 squared minus 4 equals 0. So x minus 1 squared equals 1. So x minus 1 is plus or negative 1. So x is equal to 1 plus or negative 1. So x values is 0 and x equals 2. Because we already know that x equals 2, what is the other one? Well, the x value x equals 0. Now we just shove it back into the equation. So g of 0. What am I doing? It's an x-intercept, so it would just be 0 and 0. So the coordinates will be 0, 0. Find the coordinates of the other horizontal. Okay, yeah. 0, 0. Perfect. There we go. Next question. Let the graph of h be the transformation of the graph f where the transformations have been applied in this order. So, for the function f of x, so this is what has happened. So, f of x equals x squared minus 4. And we're going to apply this transformation. So, the first transformation is a dilation by a factor of half from the vertical axis or parallel to the x-axis. So parallel to the x-axis. So we can say, to write that, we would have to write f, that'll be 2x, which will be 2x squared minus 4, which is equal to 4x squared minus 4. Now, the next part is a translation by 2 units to the right. So, now let's call this the new f of x. Now, what we're doing is we're going to now transform it more. So, we're saying that f1, so translate it 2 units to the right, we're going to say x minus 2 is equal to 4 x minus 2 squared minus 4. So, your actual, so h of x, so now h of x is actually 4 x minus 2 squared minus 4, and state the rule of h and find the coordinates of the horizontal axis intercept of graph. Okay, so we're just solving for the x-axis, so that will be, if I'm going to do it over here, so 4 x minus 2 squared minus 4 equals 0, x minus 2 squared equals 1, so it's x minus 2 plus or negative 1, x is equal to 2 plus or negative 1, so x is equal to 3 and 1. Okay, so set the rule and find the coordinates of the horizontal axis. So, okay, so because these are your intercepts, so it will be 3, 0, 1, 0. Okay, perfect. All right, question 6. An online shopping site sells boxes of donuts. A box contains 20 donuts. There are only 4 types of donuts in the box. They are glazed with custard, glazed with no custard, not glazed with custard, not glazed. Okay. It is known that in the box, half of the donuts are with custard. 7 over 10 of the donuts are not glazed. These are glazed with custard. So a donut is chosen from random from a box. The probability that it is not glazed with custard. So we want to find the probability that it is not glazed. So glazed, not intersection Oh, well, yeah, intersection custard. That's what we want to try to find out. So I'm going to draw a true diagram over here. True diagram will help. So because there are 4 types of donut. There's glazed, so we can say glazed and non-glazed, and there is custard and no custard. So right, custard, no custard, custard, no custard. So we know that half of the donuts are with custard. Half of the donuts are with custard. So, okay, that's useful, but let's look at the next one. 7 out of 10 of the donuts are not glazed. So not glazed, so this is 7 over 10. So this one is 3 on 10. And 1 over 10 of the donuts are glazed with custard. So are glazed with custard. That's 1 over 10 over here, which will be 9 over 10 over here. So we want to find the probability that it is not glazed. Okay, so what we want to find is that. So to do that, what would we do? Well, if we know that the probability of if we know that the probability of donuts are custard, so we know so we know that the probability that donuts with custard, custard. So custard is the probability of G intersection C plus the probability of G dash intersection C. And that's what we want to find, that G dash of C. So we're going to say the probability of C minus the probability of G intersection C is equal to your probability of G dash intersection C. So probability of C is half from what we know. We know it's half, minus your probability of G intersection C, which is 3 times, so 3 over 100. Is that right? So G intersection C, yep. And we multiply those to get that. Wait, half of the donuts are glazed with custard. Wait. Half of the donuts are glazed with custard. So glazed with custard. Oh, okay, no. What am I doing? So this over here would be, so donuts are glazed with custard, so it's 1 over 10. So that will be 4 over 10, which will be 2 over 5. 2 over 5 is your answer for that one. So 2 over 5. Okay, next question. It says the 20 donuts in the box are randomly allocated to new 20 boxes, so new 2 boxes. So box A and box B. Each new box contains 10 donuts. One of the 2 new boxes is chosen at random, and then the donut from the box is chosen at random. Let G be the number of, so G is the glazed donuts in box A. Find the probability in terms of G that the donut comes from box B given that it's glazed. So we want to find where that comes from box B. So let's say B, given that it's glazed, which would mean that we want to find the probability of B intersection G and also the probability of G. So I'm going to do again another tree diagram. So I'm going to do a nice tree diagram over here. Okay. We have 2 boxes. So let's say this is A and this is B. Okay. All right. And we know that blah, blah, blah. So there will be glazed, non-glazed. Glazed, non-glazed. Okay. It says 20 donuts are around. So each new box contains 10 donuts. So there'll be half probability for each of those boxes. And we know that the probability, let G be the number of glazed donuts in box A. So glazed donuts, so this will be G over the total number in that box, which is 10. Okay, so this one will be 1 minus, so what's 1 minus G over 10? This here would be 10 minus g over 10. Okay, that's... let's see. What's next? So, we want to find B intersection G first. So, B intersection G. How do we do that? Well, what do we know? One of the two boxes chosen random from a box of this. 20 allocated to... Wait, so to 20 donuts in the box are randomly allocated to new box A and box B. Each new box contains 10 donuts. So, this one will be something like 10 divided by something divided by 10. One of the two new boxes is chosen at random. So one of the boxes is chosen at random, and then the donut from the box. Let you be the number of glazed donuts. So, okay, wait. Oh, no, this question's with this, okay. Because they're in the same question. Okay, glazed donuts. So what is actually, wait. If we can find the probability of glazed, which is, in this case, it was, so we know that not glazed is 7 over 10. We know not glazed is 7 over 10, so it will be 3 over 10. Glazed, so it will be 3 on 10. That's what we know. And we know that the probability of glazed is equal to the probability of box A intersection G plus the B intersection G. And we want to find that B intersection G, so it will be probability of G minus the probability of A intersection G. So what's the probability of G? Well, it was 3 on 10 minus probability of A intersection G. So A intersection G is this one over here, which is G over 20. That's 6 minus G all over 20. Okay, now we know that this value is the probability of G. Okay, what is the probability of G? Okay, we know the probability of G is already 3 over 10, so it would be your probability of B given G is 6 minus G over 20 divided by 3 over 10, which is just 10 over 3. 6 minus G over 6. Is that right? Looks okay. Yeah. Hope that's right. Yeah, that's your answer. Okay. Oh, yuck. Okay. So, the online shopping site has over 1 million visitors per day. It is known that half of these visitors are less than this. Let P be the random variable representing the proportion of visitors who are less than this. 25 years old in a random sample of 5. Okay, so n equals 5. So we want to find the probability that P is... Okay, we don't want to use normal approximation. So we're going to probably use binomial. So we'll say X is binomially where 5. And what's the probability of success of getting 25 and less? Half. So knowing this, and we want to change that P hat. We know that P hat is X over N. And we want to, so we know that P hat's already 0.8, and we want to multiply it by the value of N, so multiply by 5, which is like 8 over 10 times 5, so which is 4. So your X value is equal to 4. Okay, so we can say we want to find the pretty much probability of X is greater or equal to 4. And I know that it will equal, so it will be probability of X equals 4 plus the probability of X equals 5. And that will equal, so it will be N, so our N value is 5, choose 4. Probability of success is half, so half, 4, half, 1, plus 5, choose 5, half, 5, half, 0. So 5 choose 4 is 5. which we want, so that'll be 1 over, so 16 times 2, 32, plus, that'll be 132 also, this one's, yep, so 132, which would mean 132, which is 632, and that simplifies to 3, so 6 12, so 16, 3 over 16, yeah, 6 12, yep, 3 over 16 is the most simplified form. All right, question 7, okay. So it says the random variable x has the probability density given by this. Let k be a positive real number, show that, okay. So what we can do is we take that k out and we find the integral from, let me just make it nicer. So we want to find the integral from 1 to 2 of the value, so 1 over x squared, which is just write it more basically, so x negative 2, x negative 2, negative 2 dx, which is equal to k. So it will be x negative 1 over negative 1 from 2 to 1, which simplifies to 1 over x, 2 to 1, k is half minus 1. And we know that, what? Wait. What have we done here? Wait, so have I done everything right? Yeah, so if I add 1, so, add 1, so when we divide by negative 1, so it'll be negative, oh, I forgot the negative here. I forgot that negative over here. That's why I'm confused. Okay, yeah, it did, probably came out a negative. That's why I was very confused. So, equals k is negative half minus negative 1, which is k is 1 minus half equals 1, and therefore, so half k equals 1, so k must equal to 2. There we go, so we've shown that, okay. So find the, expected value. So to find the expected value, it is, so it's, to find the expected value, it's actually, so your expected value is from normally 1 to 2, k, I'm just going to write the function just as a formula, because it's 2 marks and we need to show how to get expected value. It's x multiplied by f of x dx, which in our term would be, okay, so we're saying we'll pull that k out, again, we'll pull that k out, and if we're multiplying x, it'll be 1 over x dx, and we know that it will be k natural log e of x from, oh, I forgot that's 1 to 2 here, 2 to 1, so which will be k, so what's log e 2 minus log e 1, which is just 0, so I'm not going to write that any. Okay, and we know already value of k was 2, so it's just 2 log e2. That's your answer. Okay. All right, question 8. The gradient of the function is given by this. The graph of the function has a single stationary point. Find the rule. Okay, so I'll just integrate it. So if I can integrate this, and that's just like x plus 6 half minus half x minus 3 over 2 dx. Now, I know that this will be, okay, if I integrate this, we're saying, add 1, so it will be 2 over 3 x plus 6, 3 over 2, minus x squared over 4 cos x, so we put a 2 and multiply by 1/4, half, so it's, yep, minus 3 over 2x, okay, plus c. Now, we know, so, okay, this is y equals blah, blah, blah. Now, we know that when when x is equal to 3, it's y is equal to 29 over 4, so we can say 29 over 4 is equal to, so 2 over 3, so x is 3, so 3 plus 6 is 9. So what's the square root of 9? So 3 squared is 27. So multiplied by 27, okay, minus, so what's 3 squared, which is 9, so 9 over 4. 3 times 3, so minus 9 over 2, plus c. Let's simplify this further, so 9, 4, 18 minus, we can rewrite this as, we're saying negative 9 minus 18, so that'll be negative 27 over 4 plus c. Okay, we're nearly done. Coming over here, we can say 29 plus 27, so 29 plus 27 will be 56 over 4 minus 18 equals c. And so that'll be, what's 18, 4, so 8, 16, 24, 32, 32, 4, 5, 6, 7, so 72. So we're saying 56 minus 72 is, if I'm not mistaken, is 14 plus 2. So it'll be negative 16, so negative 16 over 4, so negative 4. So your c value is negative 4. Okay. So your c value over here is negative 4. So your overall function, so y equals, okay, so y equals 2 over 3 x plus 6, 3 over 2 minus x squared over 4 minus 3 over 2x minus 4. That's your solution. Okay. So the questions have been basic. So from the questions, all these questions have been just basic textbook questions. Determine the nature. Well, I can do this quicker by just finding the double derivative. So dy, okay, d squared dy. Okay, we have to write d squared y dx squared is equal to, so it's, what's the interval? So it's 1 over 2 x plus 6 minus half. Okay. Now, because we want to find it, what's like at x equals 3, so we want to say d squared y dx squared, given we want to find it at x equals 3, so that will equal 1 over, so we put a 3, that'll be 9, so it will be 3 minus half. So we're saying 1 over 6 minus half, it's equal to, okay, 1 minus 3 over 6. So it'll be negative 2 over 6, negative 1/3. Because it's a negative number, it means it will be a maximum value there. The determine the nature, so at this point, 29 over 4, it will be a local maximum. Okay, done. Okay, done. Next question. Okay. So consider the unit circle x squared plus y equals x and the tangent to the circle at point P shown below. Show that the equation of the line that passes through point 8, so this is point, so point A is over here, and point and P, so this one is given by this. So we want to find this line over here. So we want to find the equation for it. How can we do that? Okay, what can we see? Well, we know that this value here is 1, because the radius is 1. We know that this value over here is 2. And we know it's a right angle triangle. So we can actually find the theta here. So find the theta here. So if we find the theta, and we can use tan theta, which will give us the gradient of this graph over here. Because it is a right angle triangle to it, we can use the normal, so the gradient of a normal, to actually find the equation of this line over here. So let's try to do that. So let me just go back. Okay, theta. So what I'm going to do is, okay, so this will be your hypotenuse, which we don't know what it is. That's 2. Okay, so it's wait, what am I doing? Okay, wait, what am I doing? That's not your hypotenuse. Your hypotenuse is over here. So this, oops. So this is your hypotenuse over here. So this is your hypotenuse. This is your opposite, and this is your adjacent. We have the adjacent and the hypotenuse, so we can use the cos graph. So we can say cos, let me zoom out. Okay, so we can say that cos theta is equal to half, which theta can be pi on 3. Okay, so if we know theta's pi on 3, we can say the angle pi on 3, we can say, okay, we know that the tan theta equals your gradient of the line, this line over here. This line over here. So let's do that. So, okay, so tan pi on 3 equals m. So your m value is, so let me just draw it. Right, so that'll be pi on 3, so this will be root 3, 2, 1. Pi on 3, so it'll be root 3. Because we want to find the normal to get the equation of this line over here, the gradient of that graph, so we would normally use, so the m to the normal is -1 over root 3. And okay, we got it. And we already have a point over here that passes through the point, so we can use, well, we know that y minus, which is 0, equals -1 over root 3 x minus 2. So y is equal to -x root 3x plus 2 root 3. Is that right? Yep. Looks perfect. So that's your solution for that one. Done. Oh, okay, okay. Done. Let's look at question B. So it says, okay, so this transformation where Q is in all reals but with the exception of 0. Okay, and let the graph of the function h be the transformation of each line that passes through point AP under T. Wait. So it says let the graph of the function h be the transformation of the line that passes through the points AP and T. So A, P, T. Okay, and under T. Okay, so it's a straight line. So find the values of Q for which the graph intersects the unit circle at least once. Okay. So Q here is just a dilation by a factor of Q parallel to the y-axis. So if I'm gonna not mistake, pretty much it. So we have this equation. This equation over here. Let's write it as y equals x over, so -x root 3x plus 2. What happens is that Q multiplied, so it becomes a new function, which is h. So your h value would be -x root 3 plus 2 root 3. And it means that it affects both the gradient and the actual y-intercept, so that Q value. So let me just expand this, so it'll be h -qx root 3 plus 2q root 3. Now, knowing this, find a value for which... Okay, say that q... Okay, I'm going to rub everything off here because it's too much. Okay, let me just rub everything off. So we're saying that q originally is 1. So 1. Q is originally 1, and this is how the graph looks. This is how when q is negative 1. So when q is 1. So what would happen is that it touches at 1 point, perfect, on the graph. So that is the maximum. So we know that q will at least be equal to 1. And if we flip it, so we can say that q, if we put the q negative 1, which is just a reflection of it, so it will reflect, it will still touch at that 1 point. So if we reflect q, so you know how q is equal to 1? If we reflect q equals negative 1, because if q is negative 1, it pretty much reflects the whole equation reflects it on the y-axis. So, okay, we know that. So, and any values between those, so any values between negative 1, okay, any values between negative 1 and 1 will give us, it will always intersect at 2. Okay, so okay. So can we, well, I'm going to double check it because we have this equation over here. Let's say that q is half. So if q is half, we're saying negative x 2 root 3 plus 1 over root 3. What happened is it's still a negative gradient, but its y-intercept decreased, so it will be over here. And if we do that, yep, so it's still touching. So yeah, any values between negative 1 to 1, because yeah, those are the maximum values. Because if we go above those values, let's say q equals 2, we're now going above and beyond the actual. So if we went beyond, say, beyond 1, what would happen is the y value starts to increase. Now, then we won't be able to intersect the circle anymore. So yeah, what we can say is, for this one, your answer should be q is an element from negative 1 to 1. Is that right? So find the values of q for which the graph intersects at least once. Yep. Oh, what about we consider the case when q equals 0? Let's consider that case. So if q actually equals 0, what would happen? Well, it would just mean that it will become just y equals 0, which would be this. Wait. Because it's a dot, so if we say 0, what will happen? Okay. Wait. Let's try out. Okay. Because we know, okay, let's expand this. So we know that x dash is equal to x, y dash is equal to qy. So your y is just 1 minus, so wait, your y is actually just, wait, y dash is equal to qy. So your y value is y dash over q. So if I know that, and I sub it into the function, so it'll be, yeah, so it'll be y dash is equal to, yeah, q negative x, yeah, so it's still the same, plus 2 root 3. And if q is equal to 0, if q is actually equal to 0, what does that mean? Well, it means that your y equals 0, which, well, if y equals 0, wait, if y equals 0, what happens? Wait, so we still touch at these 2 points. Am I doing something wrong here? Wait. Let's say, so we know that q is an element of all reals with the exception of 0. Ah, No. They tell us it's not including 0. Oh my god. Okay, that's why I'm so confused. Wait. So if they're telling us it's the exception of 0, okay, because it does actually. So we have to write exception of 0. Yeah, we do not consider that value. Yeah, I was just confused because it still touches at 2 points. So it still touches at 2 points. So why is that right? Yeah. Okay, perfect. I hope that's right. Find the values. Okay, let's next one. Let the graph of H intersect the unit circle twice. Okay. Find the values of Q. So find the values of Q for which the coordinates of the points of intersection have only positive values. So, okay. So the X and Y values have to be positive. So they must all be in the positive quadrant. So I'm just going to rub this off and show how this may look like. So, we need it to intersect. So, okay. What I know is because you know how y equals, when q is equal to 1, it's the blue graph. And when q is equal to 1, it intersects at 1 point. And if we decrease q, if we decrease the value of q, what happens is we start to actually get, two intersections. That's true, we want two intersections. So if we decrease the value of q, so we'll get, so like a small here, we'll get one here, and these are the positive. So we only want them in this positive quadrant, so this quadrant over here. To do that, what we want is we want to make sure that it goes like this, but maximum we want to hit it to this point over here, because if we go below that, we get negative x values. But we want all positive coordinates. So, okay, so what we know is we can, okay, if we find what's here, so which is 1, that's 1. Okay, let's just do this slowly. So, we know that the q will equal to 1, your max value will equal to 1, but it will not include it because it's only 1 intersection and we need 2. And we want to find where the gradient is pretty much, where the y-intercept is equal to 1. So, I know h of x is here. I know h of x is over here. So, we can say the y-intercept, so 2q root 3, we want it to equal 1. So 2q root 3, q is equal to root 3 over 2. So and we can so q equals root 3, and it's including it because at that point we do get 2 intersections still. So, okay, we can say q is an element of, what was it? Root 3 over 2. So root 3 over 2. And 1, not including 1. Is that right? Including no 1. Okay, so we get 2 intersections at that point. We only get, and below that we'll all get value. Okay. Yep. Looks, or maybe it's, yeah. I'm not too sure. This is hard. This question over here. Yep, is this the last? Okay, perfect. This is the last. Okay. Let's finish this off. And yeah, so q is between 0 and 1. Let P be the point of intersection of the graph of H of the unit circle, where P dash is always the point of intersection that is closest to A. Is shown in the diagram. Okay. So let G be the function that gives the area of the triangle O. So OA. So wait. So OAP, which is OAP, which is, yeah, just this triangle over here. So in terms of theta, define the function. So define. So we need the rule and the domain. Well, the rule, okay, let's find. So, okay, for the rule, we know that the area of a triangle is half base times height, which we could write half. And our base value is this over here, which is 2. And what's our height? So our height value is this one over here. Well, we know that this value is 1. And, okay. And we want to find this value, x, your height. So we can say, this is our opposite and this is your hypotenuse. So we can say that sine theta is equal to x over 1. So x is equal to sine theta. So that's your height. Your height is just sine theta. So times sine theta, which equals, so this will be just sine theta. So therefore, g of x is sine theta. Okay. And we need to give the domain. So the domain, so the dome of f of g, so wait, the dome of g is from, okay, domain, okay. Well, we know that q is from 0 less than q less than or equal to 1. Yep. Okay, I'm just gonna rub these all off because it's confusing. So if q is 0, so if q is equal to 0, yeah, what would happen is the value, it would just be a flat line, so it would have no area. So the lowest point is when q we cannot include it because 0 is not included, so we can say the domain is not including 0 to what's the maximum? Okay, the maximum is 1, by the way. What's that? So when q is equal to 1, when was it? So this one was q, it was equal to 1. This one was q is equal to 1, this here. So we can use that to our advantage. So this point over here was q equals to 1. What was the angle? This angle over here? Pi over 3. Pi over 3. So pi over 3, is it included or included? Here they tell you it's included for and that. Okay. So to define it, you would just say g is from 0 to pi on 3, close bracket, goes to all reals, g of x is equal to sine theta. Oh, sine, what am I doing? So I'm supposed to say sine theta is equal to this. Have I done anything? Looks right. Okay. So normally this is the last question, so it's the hardest one. So this one's probably going to be a hard question. Determine the maximum possible area of the triangle OAP. Now, so if we can find g dash of x, which is your area, which is cos theta, and we want to find the maximum value. To find the maximum value, we know that when we let cos theta equals 0, for only the domain of 0, not included to pi on 3 included, what's that? So if I'm drawing that, so it will look like this and this. But, so this is pi over 2. So it will be around here. So this is only the domain we can go into. So if we, here is maximum. When it causes 0, it's a maximum. It looks like it's a max because it's higher. Is that right? So when theta is equal to 0, it becomes a maximum. Let's check. To check, so imagine theta is 0. Okay. No. When theta is 0, I just forgot. So when theta is 0, it pretty much, so imagine this angle over here is the area. And if theta becomes 0, we're saying that, can you see how this over here is your area? And as we decrease the line, the area becomes smaller. So if we decrease this over here, this theta to 0, it becomes 0. That's not your maximum value. So your maximum value would be, if it's pi on 3 would be over here. Pi on 3, which is from here to the tangent, which, yeah, it gives the most highest actual area. So knowing that, so when, okay, and we can actually let it equal because it's included too. So is that right? So if we say cos so the theta is equal to pi on 3. So determine the maximum possible area. So an area is g pi on 3. So sine pi on 3, which is root 3 over 2. Is that right? Root 3 over 2. Wait. I'm not too sure if that's pi on 3. Let me just double check. Okay. Yeah, this question's actually so it's not too bad, but it's tricking me somewhat. I know for a fact there has to be a trick into it because it's the last question, and normally the last questions are not this easy. Let me just highlight this and just bring it over here and say, so theta is equal to pi over 3 to with root 3 over 2. So pi over 3 is over here. Okay, so pi over 3 is here. Yep. So it's when it's tangential. What about if we increase the more? Oh, well, that's the only maximum doing. What about if we lessened it? So maybe between over here. So we did that. It means, oops, it means this. Okay, still, yeah, it just makes it less. Where it's in comparison, if you did to this over here, you get more area. Yeah, so pi over 3 looks right. So, and we just want to write unit squared as your answer too. All right, is that it? Okay, I hope you guys enjoyed this video. Look, I'll be honest, this exam, it's not too bad. I had all questions that were textbook style questions until the last question, which was just, they just give us some little alright difficulty. You just had to use your imagination to find that. But yeah, I hope you guys enjoyed this video. Make sure to please like and subscribe to this channel if you want more videos. I will be making videos for exams for physics, chemistry, specialists and methods. And yeah, if you guys want tutoring, I do tutor 1-to-1. And if you guys want, you can email me through this email over here. And yeah, it's also, my email is linked down below. So yeah, have a good day, guys, and make sure to